So let us start with the introduction. Welcome to our sixth episode of our podcast on collaborative hardware and hardware and software prototyping, powered by passionate minds. So, would you like to introduce yourself?
Sure,
Wait,
Anushka,
he is saying that I am not audible. I'm audible to you?
you are audible. Yes, yes, you
Yeah,
are audible
yeah.
to me,
So, yes.
loud and clear.
Okay. So
Okay,
let's start with the introduction.
yes, sure. First of all, thank you so much, Anushka, for inviting me on this podcast or whatever face-to-face seeing on this platform.
Yes.
I have seen your work while interviewing a lot of at least five previous podcasts, and you are doing a very good work in
Yes.
terms of community building. I have seen all these heroes, uh, Paul, Marmek, at least one more Atulji on this podcast. All these are very inspiring talks. Uh, with that, it's very difficult for me to be on their shoes, but I will try. So I'm not teaching here. Basically, I'm just a student like you guys, Aviram, Mrinal, Anushka.
Yes.
So take me as a student, and we will learn this together.
Yeah.
And yeah, so this is the start. Let me introduce myself. My name is Swapnil Sapre, and I am a senior leader in one of the cutting edge US based company, Ambient Scientific, and we create one of its kind, a very unique AI CPU, which is very tiny, and in general, this is based on the ultra low power consumption requirement or use cases. Basically, we use matrix compute and analog in-memory compute to achieve this. Of course, I am not here to talk more about my company and all. So I have, maybe we can maybe discuss this if you find comfortable in some other podcast. So I have around 22 plus years of experience, okay? And I started, into RTL designing uh, with Wipro. Then I was with NXP Freescale for their ARM platform based SoC emulation, verification, validation. So I had a privilege of working on the Moto Razor mobile platform and ensuring the complete verification and validation of that particular you know, platform. I was also involved with AMD for their SoC fusion projects. So when I joined AMD, we had just acquired ATI Graphics, okay, which was a competitor for NVIDIA almost 15 years back. So my responsibility, I was a senior engineer, just going to the member of technical staff kind of role, and our my major responsibility as part of the team was to mm, test and verify the bus between UNB, which is basically a CPU based platform. Again, integration with the GNB, graphical not bridge. So basically, CPU and GPU, they were coming up with a novel concept of actually putting two chips on one die, and they used to call this SoC fusion. That was a very big milestone in AMD to consistently start, overshadowing Intel from that particular era, and then they never look back. So basically, yes. So starting from RTL, SoC design, verification, validation, and then I was also involved with a lot of FPGA during my old days in NXP as well as AMD. Uh, Last 10 years, or 10 to 12 years. Basically, I made a conscious move from chip to the product side of it. So I took a plunge as part of my movement from AMD SoC to the uh, Western Digital SanDisk in their product lines. So it was a very nice experience. I'm basically from the fabulous chip, which you cannot see unless, I mean, the layout and all those are the only visible aspects of the chip you have, till the packaging, production, supply chain, production testing, design validation testing, how the chip is qualified, qualification, chambers, PVT, characterization, firmware development, use cases, product line, in the retail, in the OEM sector. So all those things are actually not visible to the chip design engineer. Okay, so I was very fortunate that I could actually see all those things, all those system related areas like power, performance, all those things I was exposed. Last 5 years or approximately, I have been working with leading basically the entire chip activity in ambient scientific, from RTL GDS to production till the complete package OSAT, doing the board design ourselves, and of course the software development kit, design validation kit, which goes basically to the customers. Okay? And then we have a separate team. We have a small group basically, but all this is innovation driven core group. So we then hand over the SDK, DVK, after our own compiler for the AI core and GPX10, which is our flagship chip, and then we give it to the customers. And my role also extends to the customer support, field application engineering, demonstration, and giving them training. So
Yes.
this has been the complete utilization of my last 15 years. Whatever I have learned, I'm able to manifest and implement this in this company. So this is my introduction, Anushka.
Yeah. So let us start with what does with the so the title of the podcast was collaborative prototyping, right? So we will start with that topic only. So our first question is, what does collaborative prototyping mean to you, and how it can be effectively implemented?
Okay, very good. So let us start. Before I answer this question, I think we have around 1 hour approximately. I want to set up some rules, in between us. And as I said, first rule is I am a student, and we are all learning here. We are all human beings. Uh, we are not. We are not. I won't. I mean, I would definitely like to avoid questions which are political questions or some opinions related questions. We are all here to learn something, and I will be learning with you for next 3 months, 9 months, hopefully next 30 years. Okay,
Yes.
so some disclaimers I want to put, that whatever I am putting forward as views and opinions, right? They're all entirely my own views and do not reflect any of the AICPU or ambient scientific, okay, things. Second is of course we make in India is very hot topic. All of us, you guys are all young people. Bharatiya semiconductor, make in India, India made, and all this. Of course, I'm all for it. Okay, but at the heart, we are all engineers. Okay, for me, and I think for basically all of us, right? Chinese mother, US mother, or Russian mother. I mean, all are same. All are same in the sense, if they are not not well, it's as an engineer my duty to come up with some solution gadget to help them. Well, that is the basic premise. So, make in India is of course very much our priority. But before that, as I said, like we are human beings and we are engineers, and with thought process, I think we should move, and we will focus introvert journey. How can we improve ourselves and not go into a lot of things to set up the context. Then another thing is, I would like to learn from you also. For example, when we talk about this collaborative roadmap or collaborative path, right? Uh, it's basically in my process. I mean, we have been doing this for a lot of other scenarios also. So, since you are my partner, our mentors are our partner, and the students are our partner, right? So, we want to know one of your project which you have actually done. Probably, what are the limitations? What are the gaps? And we should be able to process wise, follow on and fill those gaps. Okay? So that is the kind of questions I'll be asking you also, so that we can set the correct roadmap planning and things. In my opinion, all those collaborative work is basically uh, you know we need to do a better program management execution, and then I think uh, forgo our self-esteem, probably we should be able to achieve. That is it. Okay. This is, as I said, like, I mean, nothing to do with, I mean, all of the tools are available. We will talk more about those things in detail, but we should help ourselves by making more disciplined, more process oriented, and I'm sure by doing those things we should be able to achieve what we want. Another and last probably point is, of course, commercialization is the end goal, but we want to also ensure that we talk, at least in this session, till the prototype part, because prototype to commercialization are very subjective things. And I leave it those frameworks, those guidelines, we should work together with our mentors or whatever to ensure that what are the criterias or categories or parameters for product prototype once done to the production or commercialization. So these are some of the I should call as disclaimers. Now, coming to the objective of this whole episode, basically what we want to do is, let us uh, talk about some of the open items among ourselves, and we will based on our learnings, your learnings, and my thought process, and the questions we basically take on, we will publish our execution plan. Okay, so that is what we will be doing. Of course, since we agreed, or we find that FPGA based things have to be taken up for the natural advantages. Okay, we will talk more about those kinds of things, and yeah, we will ensure that we do our best to go till the prototype to production or whatever commercialization stage. Okay, so coming back to your question. So your question is about why community development is real and possible, correct? So as we all know, I mean, before COVID, post COVID, okay, the things have drastically changed. People started to realize that we can work remotely. We need not go to office, and there have been a lot of improvement with respect to the open source initiative, not only at the chip or FPGA side of it, or maybe Arduino, Raspberry Pi, or Open FPGA, Open chip, Open LAN, Open whatever, silicon compiler, and all those things, correct? But of course, from the point of view of PCB but designing, mechanical enclosure designing, you call it about cloud and virtual lab. in terms of AWS Cloud FPGA, RISC-V, TinyML, TensorFlow from Google, okay, KiCats, of course, Open PDKs. From the point of view of program management, also maybe WhatsApp, Discord, groups, and of course, LinkedIn has in the last 8 to 10 years, LinkedIn has done a phenomenal professional networking, the job of bringing a lot of such people. Now it has become very mature platform also. Okay, so this has all, of course, then Slack, Git, GitHub, YouTube, and those kinds of things have been there. Uh, in some way, how to showcase our prototype, or how to showcase, or how to bring two different people from two or three different geographies has been very successful also, from the point of view of various sharing platform for knowledge, Reddit, maybe Stack Overflow, Archive, Medium, Instructables, Hackster, Hackaday. Okay, so all these are, I mean, as you have been discussing in, I mean, we also know in our past podcast, right? So, internet has been phenomenal source of learning. So again, teacher does not teach, student learns. I mean, it is up to student to, if there is a river, it's up to student to take a bucket full of water or a jug of water. Okay, how much ever is the capacity of the student, he will take. So that has been the source, the internet has been. And of course, we should utilize, as long as we agree that hardware can run on cloud, hardware can be remotely accessed. uh, Software is important. We cannot just isolate software. If you people have just done your specialization in hardware, so we should think from the system point of view. So semiconductor is, or chip is nothing without the software running on top of it. Software people cannot be feeling okay, they are the last source of customer support, but eventually they have to learn hardware. I mean, that is what is the complete 360-degree handshake has to happen, right? So any product again is just not about hardware, software. There are different shades to interdisciplinary part of it. I mean, in my opinion, I call this system product solution, right? So I mean, this is what is the learning so far. So collaborative approach is about respecting that a hardware person has to at least get into the field of software. Wherever the overlap happening, software person should go to the field of hardware where the overlap is happening, to do the individual job properly. And then there are a lot of funding and early access platforms like Indiegogo, Kickstarter, okay, and which are again doing a great job. A lot of material from the universities like MIT, NPTEL, IITs are available. From the you know crowd supply, Tindy, those kinds of platforms are available. And internet has been very open, so that now a person who is, say, 8th, ninth, 10th, 11th, or 12th grade person, or who is undergrad person, who is looking for a postdoctoral, or doing PG, MTech, BTech, whatever, right? Or person who is also working on some of the companies. Basically, they are all at the, it's all about will. You will have skills, you can learn skills, of course. You have some natural skills, you can have some natural orientation towards something. But if you are willing, if you are ready to become student, I think nobody is stopping. So I think that is what probably is, I would say, is the highlight of my view, and the people have been experiencing and manifesting the collaborative hardware software approach to making a prototype or making a product. Go ahead, Anushka.
Yes. So how we as a community should start with collaborative projects? We are actually working on one project.
Yes. So, of course, as I said, right, FPGA is one very nice tool. Okay. First of all, we have to realize that we agree that only hardware cannot be the complete prototype. Only software cannot be a complete prototype. You need, while doing a prototype or making it a commercialization, you should have some kind of learning roadmap so that you can use the same thing for the next. Now, when we say how should we collaborate, of course, we all agree that we are probably at different locations. Now, that location is definitely not a limitation. Uh, FPGAs, to start off with, give a very nice starting point. Okay, for the simple reason that when you are talking about ASIC, so FPGA flow, ASIC flow, I mean design spec architecture to the GDS generation or bit stream generation, they are equivalent. Okay? So you get a nice front end to the back end. I mean, all this STA, SDC, gate level simulation, flow planning, placement, routing. Of course, the tools are different. Here you are basically talking about AMD versus Intel or Altera. But at the level of ASIC, you are talking about Cadence, Synopsys, or Siemens. But the concept wise, of course, they are same. To add to this, there are some open FPGA. There are lattice and probably a lot of such, which also give the earlier we used to consider these tool chains are very complex. Quartus, Intel, Vivado, Vitis, they have given nice, and also we are also now in the level that the very core value of a product, which is hardware and software, is very much possible and available in terms of today's FPGAs, like you call programmer logic, programmable system, PLNPS, right? So you can have actually implementation of a software CPU core. You can have you may want to have a hardware logic also. So rather than just implementing an encoder or probably something only which used to happen only in Cyclone or probably Spartan old series up to that, we are actually have Agilex, which can implement Neos, RISC-V, neural NPU also it can be implemented. The tools are freely available. Okay, to implement this, simulation tools are also available. Same is the case with your AMD scenarios. Okay,
Yes.
so the hardware and software. Not only, I mean, once you implement this, then hardware engineer is basically invited to run some kind of embedded code on top of it, also, right? So I mean, I keep saying, if at all you want to pursue or you want to enter in your career, at least some point in time, maybe you should start in FPGA, so that your fear of lab, fear of measurement, fear of adapter connectors, DSOs, I mean, again, as I say, right? So FPGA not only is for software hardware, basically you can debug, you get hands-on, stuff in terms of what are the connectors, what are the different types of modules, going away from just FPGA implementation RTL to bitstream generation. There is a scenario called as post post implementation validation. So maybe you are working on some camera pipeline, maybe you are working on some audio pipeline, maybe you are working on some sensor fusion pipeline, right? So basically, what happens? You have done video buffer, you have done some kind of DMA, you have done some kind of all those maybe signal processing FFT stuff, but finally you are encouraged, and it's necessity that we have to basically test the camera connected, the microphone connect to it, the display connect to it, and maybe multiple sensors. So this is what is more important to start off. With. So FPGA is very nice platform for the for this kind of approach. Now problem for us is how to use FPGA, how should we, where should we have a lab infrastructure, where should we have, can we use some kind of cloud, can we use some, our bench level, can we design it, can we test it, can we simulate it, okay? All those things are part of our project life cycle. Okay? So for this community projects in future, from requirement engineering till the FPGA RTL design implementation, some innovative signal processing, pre-processing kind of thing. Finally, what kind of software it has been implemented. The idea is that we should ensure that an IP is integrated with the CPU or on a bus with the software, or maybe it can be just taken as an IP core on its own. So, for example, you are working on some FFT for power or distress or anomaly detection kind of FFT based on the power spectrum. Why don't we take it to the windowing level, overlapping level, live streaming level, and create a prototype out of it which is visible? So there
Yes.
are challenges, of course, in terms of how do we touch FPGA, how do we program FPGA, when something fails, how do we see in the LA, when should we connect, and how can we demonstrate. So those are the things we'll have to know. This will be part of our execution plan.
Yes. So, from your experience, what are the biggest gaps in Indian engineering curriculum and when it comes to hardware and embedded systems?
Okay, so this is a good question actually. Uh, uh, Major difference which I see, again, not basically very specific to India, but I mean in general, right? As we said, like I mean, uh, the problems which we are solving are needing different kind of subject understanding. So it's maths, it's physics, it's biology, right? In our universities or in colleges, basically we are taught about projects which are very specialized projects. Even when you do some PG diploma or MTech and all those things, right? So in general, we are very happy to call, okay, I did PG diploma in UVM, I did PG diploma in physical designing, PG diploma in this is post engineering or things like that, right? So what I think what should have happened is uh, we should be focusing more about the system and product centric. So this has been our little bit of limitation from the Indian curriculum, that we are not able to collectively think about manifesting or implementing product approach. So that is what the government has probably understood. A lot of veterans have been talking about this, that we should have a product centric approach. Uh, I mean, we work on ASIC design for almost 25, 30 years of our life. We work on embedded software for quite, I mean, lifespan of our thing. But from the grassroots level, I believe it is basically both bottom up and top down approach. So the bottom up approach is you learn small, make it big. At the same time, you should also get some exposure to the use cases, to the application, to the big picture, and go down till the bottom side of it. So in whatever bits and pieces we have been trying to do this. So basically, what happens? Whether you are doing UVM, whether you are doing FPGA implementation or RTL, a big picture helps. So even though you are designing a clock architecture or reset controller architecture or maybe a FIFO or maybe power stuff, of course. So the understanding of what is the use case, why this FIFO should be such, or why this is the clocking architecture or no, rather than getting this requirement, basically we should think beyond. Of course, ask why, what is why, how this chip is used by a software or at a use case level by customer or developer. So that kind of vision in the industry also not there, in the universities also not there. Okay? Very few companies, that is the reason, in India are actually product centric. So we do till, I mean, even there are very isolated big groups in multinational companies, which are maybe there are some 500 to 1,000 chip design engineers, three times of verification engineers in big companies. Maybe there will be bring up 50 to 100 people, ROM developers 10 to 15, and I'm just giving a ballpark number. But finally, the product engineers, you know, the product level or the system level uh, view is missing. So that is something is missing. How do you actually do a cross-functional check? Where is the left shifting opportunity? How can we innovate based on the hardware, software, and so all these problems basically. I mean, if you even if in normal life we talk about how do we solve a problem of poverty, how do we solve a problem of water? Okay? They are all systemic problems. So you need different kinds of groups to, or different core centric people to give the solution, but you will not be able to reach a final destination unless at least few of them are having a big view of very different uh, areas. So I think that can be improved. That is why you don't see basically any courses into system design or a product development kind of thing. This change. This should actually come from the even probably 10th, 11th, 12th class, or in our engineering curriculum. I think that will help.
Yes. So, how do tier 1 and versus tier 3 colleges differ in hardware exposure? Is it just the infrastructure or also the mindset and mentorship?
Mindset and mentorship. Okay, so let me tell you from my example. Okay, actually, I in my growth or my development, whatever has been happened for last 22 years in the journey, there has been a very less contribution of my university study or the engineering study or the 10th study. Somehow I am never, I mean, it depends from person to person, why you are studying in university, why you are studying a certain subject, right? So Are you doing a self study? Is your university curriculum good enough? Is your teacher good enough? What inspires you, and why are you doing a particular study? It all depends. I don't think it is a right no bucket to quantify. Okay, that IITs are better, or tier 2 colleges are better, or tier 3 colleges are better. I mean, it is, I mean, in my opinion, IT colleges are good in some aspects. In some aspects, it's not recommended practice for, it's totally biased. So it's a individual journey a person has to take. Universities versus European universities versus Indian universities, tier 1, tier 2, tier 3. Basically, only few things matter gradually, in person's growth, in my opinion. Again, this is my personal opinion. How intense you are, how passionate you are, okay, and how patient you are, right? So grab the opportunity. I mean, finally, people excel when they are at 45 years of age, 50, 55 years of age. People excel when they just do their maybe crack J 25 years till 35 years. They lose their energy. Okay, it's all changes from person to person. Whether you are doing entrepreneurship, whether you are working in a Google, whether you are working in a Microsoft, or whether you are working in a startup. No? So I think it's an individual journey, and there is no a common tag or common rule here to follow. As I said, right? I mean, we should only focus on our own growth. I may sound very different, but basically, I mean, I can confidently tell to you guys, because there is a, almost I can see a generation gap. Okay, this question is very difficult to answer when I'm talking to people from my generation. Okay, they will have their own views, but if you are asking me in this forum, then I would definitely say that forget about whatever is IIT, JEE, scores, CAT scores. Somebody has studied in US, done PhD. Finally, what accounts or what matters in your life is basically how passionate you are. How do you in deeply feel your work, and how do you basically how patient you are. Yeah.
Yes.
I mean, that is what Gita says, basically dharma and karma. Dharma is what is right. Okay, you keep doing. Karma is basically fine. I mean, uh, figure out, have patience, and do work with more intensity. That's it.
Yeah. So how does hands-on FPJ experience prepare for our roles in VLSI, embedded Linux, or even HPC domains?
Yes, so I think we touched upon this part a little early also. I will try to re-emphasize. So basically, what happens is FPGA is a very beautiful, hardware or software piece. Basically, what you do is eventually you are designing some IP. The outcome of the whole exercise can be IP, like you guys are doing FFT or power analyzer, or maybe some kind of image signal processing, or some kind of Mac engine, or maybe some kind of protocol converter or multiplex of certain protocol, right? So all this is possible at the IP level. Then it gives you a facility that probably, yes, you can actually see something happening in the hardware by connecting sensors, by connecting motor controllers, by connecting actuators, by connecting BLE, GPA, GPRS, those kinds of modules, or maybe human activity sensor, gyroscope, accelerometer, or cameras and all that. So you can actually see this, and this becomes a complete prototype or a solution. Of course, FPGA has a limitation with respect to they're bulky, they're costly, uh, they are power hungry. Okay, but for the demonstrating your ideas in the real life, they give you a lot of freedom in terms of preparing IP core for next level of commercialization, preparing a pipeline, hardware software pipeline, running a software program on top of it, which can basically be connected to some kind of host processor and entire design. And next level, of course, it gives you a very good open eye view of how it can be converted to an ASIC portion. So
Yes.
most of the parts are same. Your design is same. You just have to change the IPs from FPGA IP like block RAM, DSP blocks, hard coded soft blocks, whatever those kinds of things. Do a custom ASIC blocks based on the library standard cell for the particular PDK, and you are good to go. Do a ASIC simulation the way you have been doing for FPGA simulation. Do a bring up for ROM, do a bring up for C based simulation, run UVM for IP level, run SOCC level test benches, and the applications. So, so there are at least three dimensions we talk about. You can actually develop IPs. You can test your full hardware software on FPGA even before ASIC is there, and it opens your view for real life ASIC based on some PDK or that kind of thing.
So, what about the microcontrollers?
Yes, so
FPGA.
yes, of course. So microcontrollers, I mean, they are very cheap alternatives. Okay, for products or solutions, they are in general preferred when you do a mass production, right? So for STM8 or Raspberries or ESP32s or those kinds of, or maybe even RISC chips are available for less than 100 rupees, less than 200 rupees. The boards are available for less than 1500 or 2000 or so. They will definitely, and then if you are willing, basically you can create your whole prototype against this. But it is difficult to create some IPs like preconditioning IPs, or you may want to do some kind of acceleration, or nowadays these FPGAs are also programmed via Python or C. It's going towards more of the abstraction towards C or software. So we have to take a call that at what stage of our product we should use FPGA. Is it 100% FPGA, or is it 60% FPGA stage, and eventually it has to be commercialized with the microcontroller, or it should be an ASIC. Okay, so both of these scenarios, basically FPGA will help you. You can actually run FPGA hardware logic, connect to some kind of arms or Pico Blaze or Neos kind of CPU on the FPGA, run the software. You have to just migrate the piece of software from that kind of FPGA specific soft CPU core to the microcontroller's PCPU core. Uh, that becomes very handy and very powerful approach, uh, and you can actually implement full SoC on FPGA, right? So I mean, then it paves a way for mass producing a six or maybe low volume manufacturing or whatever.
Yeah. So, can you walk through a step-by-step roadmap for building such a project, collaborative project, which we discussed earlier from idea to prototype?
Yes, sure. So before I go ahead, I would like to take one or two questions from Abhiram, Mrinal, Sarah, Akshita, Seema. Uh, are you able to follow up on this discussion? Any questions you have?
I think no.
Okay, fine, good.
Yeah.
So let me share something here.
So, Mreenal, I have question. Is there any difference between ASIC and FPJ verification flow?
Okay, so in ASIC, you would know there are three parts of the story of ASIC. Basically, what happens in ASIC is there is a EDA tool, there is a RTL to GDS custom flow, okay, and then there is a PDK. PDK is the process development kit against basically you will you know build your mm, chip for. Now in FPGA, the front end and back end flow is equivalent here. You will of course do an RTL. You will synthesize it. You will do generation so that you basically program the FPGA generation of bit stream. So generation of SDC files, timing analysis, which will do a back and forth feedback for floor planning to routing against which bit cells or which logical blocks to choose is very very restricted and very very custom towards the FPGA part of it. ASIC, the steps are same. RTL, no simulated synthesizes. Of course, there will be synthesis or your cells will be different. Here, cells are FPGA centric cells. Their cells will be specific to the technology. Maybe you are going for TSMC, UMC, Global Foundry, or Skywater, whatever. So those are the parameters which change here, and we then go to the physical design flow with respect to the in FPGA it is little easy because you have basically very restricted area and only a limited number of blocks. In ASIC, you probably have a lot of opportunity to optimize area, optimize power. You can run UPF, power aware simulation, power aware design. You can do. You can customize power islanding, clocking structure. You can all do that. you know. So when it comes to functionality and software and left shifting, guys, so it is very easy to be done in FPGA. It is very fast. Whereas in case of ASIC, no, when you have to do for power optimization, performance optimization, area optimization, so that becomes a different kind of approach here. Uh, and then we have full backend flow. I mean, of course, LBS DRC for verification till GDS generation, right? So all this is little different in case of ASIC, specific to the PDK, specific to the tool to tool for you know verification till the part of physical design.
Yes.
Any other question?
I think no.
Okay, I am sharing my screen. Are you all able to see?
Yes.
Okay, so here we go. Basically, what we are doing is, uh, okay, what is the meaning of an IP? Okay, IP is an intellectual property. It can be a hard IP, it can be a soft IP, and we decide. So I2C can be an IP, FFT can be an IP, signal processing part can be an IP. A chip can be an IP. A software piece can be an IP. Okay? So IP is something which is sacrosanct, basically. But what is a good IP? Okay. So a good IP is something which basically solves some kind of bottleneck. Okay? So bottleneck in performance, bottleneck in terms of area, bottleneck in terms of integration, or maybe I mean that's what the connecting two or multiple different block. Okay. So those are some of the basic concept. Of course, as much as important in any kind of coding. Okay, IP also has to be parameterizable, reusable, modular, so that it can be carried forward from X to Y generation. And as much as possible, we should ensure that it is complying to some of the standard bodies or open standards. Right? So, for example, I mean, we are doing something. Say we are developing, some kind of IP, say FFT extended IP. We should ensure that the interface in and out from that is standard. I mean, it should be just hooked up with some kind of register file to AHBXI or Ramba bus, or maybe Avalon bus, or maybe some kind of generic interfaces. Okay? And it should have some normal standard of how this IP can be used. I mean, they should have some interrupts, they should have some flags, those kinds of things. Right? So those are the characteristic of a good IP. That it should be modular, parameterizable, reusable, follow a open standard, and of course, the origin of IP should be driven from the market or from the competitor, top to down. We realize that what kind of IP or what kind of solution we want to bring to the market as a solution or problem solution, or solving some kind of pain point. Okay? And of course, it should be, if somebody is buying it, we should think from the complete 360 degree, that enough documentation, enough how to user guides, and verification, and all those things are basically provided. Okay? So this is all about IP. Now we also have kind of discussed or concluded that FPGA are a very good in terms of starting for developing prototype. Whether you finally want to move to MCUs, microcontrollers, or maybe you want to do some kind of low volume tape out for the ASIC. So considering this, what we would probably do is collaborative approach of hardware, software, or maybe an FPGA till the level of this prototype. We will finalize on some of the areas. Okay, based on your skills or based on your will, we will figure out. We can handpick some of these things. So in terms of vision, in terms of audio signal processing, in terms of connectivity, in terms of industrial automotive IPs, in terms of security SOC IPs, right? Or maybe in terms of AI/ML. So we can pick up each and every part. This is just an indicative list, Anushka and team. There can be much more to this, but just to put forward the idea, what happens is, for example, we are talking about vision and emerging IPs. Can we do simple DVP interface? DVP interface, I don't know if you are aware, is a low power digital video protocol, which is basically controlled by so all these drones, all these sub 2 megapixel cameras, omnivision cameras, HiMax cameras, okay, all the security cameras, basically non MIPI. MIPI is an analog digital high and a high power stuff. So all these tiny devices in general will have in some most of the cases DVP interface. So it definitely needs some kind of filtering. Can we put a DVP interface, connect a camera, put a ISP for brightness, saturation, hue control, and those kinds of things? Maybe put some kind of image signal processing, or maybe extend this to MIPI support. This kind of uh, extension, which creates your complete IP, bring it to the pipeline or system level case, connect this to a XIHB bus, and program and make the complete skeleton. So similarly, multi-camera aggregator, like can we put then 4 to 8 cameras, do a kind of compression, multiplexing? Are we able to bring this up? Okay. So even if you are, I mean, this kind of things are very very difficult to be done with the microcontrollers. I mean, even you know, uh, 32-bit, 64. I mean, making this in FPGA or finally in ASIC is the right way of doing. Maybe you can connect an FPGA and to the microcontroller later. Basically, bringing up the entire system. Can we do some kind of tone mapping, auto tune, AWB, or basically come up with some kind of interesting algorithm for the signal processing? Can we show with a demo that we are able to do some kind of pass through, receive the camera, multiplex with the audio, merge with audio, scaling, and displaying to the HDMI port, understanding the efficiency bottlenecks, solving it, and something like, can we do some kind of encryption, anti-tamper logic, or the watermarking, or for the live streaming? I mean, these kinds of projects give us some kind of visibility into the hardware software system view. We would be able to test them. We would be able to appreciate that a complete encoder decoder against software working on top of hardware is established. On the similar level, I'm just giving a highlight of what we are thinking. Probably these are just 5 to 10% of the projects. We can add a lot of other projects, and we can distribute and execute. I mean, it's a matter of how do we plan to do. Similarly, on the audio signal processing portion of it, uh, audio DSP, can we do some kind of gain control, filters, echo cancellation, noise suppression? All these are parallel accelerator specific IPs. Okay, can we connect this whole audio DSP to the microphone interface, I2S interface, PWM interface, or PDA interface, and prove that okay, audio is echo cancellation is done, noise suppression is done, and maybe run some kind of edge analytics, convert it to, I mean, do a pre-processing part of it. This is all audio pipeline. In the previous, there were multiples of such video pipelines. Can we do, I mean, one of such projects you are already doing is FFT anomaly detection. But what are the opportunity for this to basically go to the next level in terms of prototyping? Okay, so when I say prototype, basically it is a complete system with a CPU attached to it, with the software running on it, with a sensor connected to it, with the actuator connected to it, and you are showing something not in the simulation, but actually in the hardware software system. Okay, now you can have some kind of software defined radio with respect to different kind of generic stack, signal analyzer, some of the connectivity IPs. Okay, this, I mean, I'll let me go through bottom to top. We all have individual SPI I2C UART core, but we never not much in terms of multiplexed SPI I2C UART on the same 3 to 4 bus. This can be one interesting part of it. Can we have CAN bridge support in a very generic kind of UART interface? Can we have a CAN? So all these are problems which in the industry we see. But generally, either we, they are not available as an IP. They are not available as a complete pipeline kind of stage. Not only a person working on this gets confidence, but we tend to get the full picture of what is happening in hardware, software, debug, and the system pipeline scenarios. Okay. Or in terms of industrial and automotive IPs, situations, or maybe energy meters. I mean, there is a lot of demand of all these energy meters, power measurement. We never have any kind of SOC which is coming from, you know I mean, even from local business market, which does the power measurement. All these are basically, very very legacy kind of power measurement ICs, either from China or from other sources. So, how to do a power measurement via ADC, RMS calculation? Can we do an SOC, do a current measurement, or probably a voltage based circuit outside with an analog differential pair to make some kind of prototype, which we can call as a pre-built SOC. Okay? Uh, Motor controller, sensor fusion. Can we connect this motor controller and sensor fusion? Like, I mean, can we have interface for analog, or maybe a UART, multi UART fusion from the IMU, GPS, and probably that kind of thing, and run pre-processing with respect to the fault handling or filtering, and do some kind of AI accelerator within the SOC, which is running software. So all these are kind of interesting projects which have potential. If not, then you generate an idea. We club with some of these ideas. We have other list, and we finalize what should be the requirement, what should be the way of doing this, and things like that. Similarly, in terms of security SOC IPs, we can possibly have some kind of full security, based on the comparative analysis. Either some of the IPs are only standalone AES, DES 128. Can we have SHA, ACC? This all as part of one SOC IP, which is security IP. Puff generation. Can we have as much as AI is popular, is been implemented in hardware, software, GPU, TPU, and all that. But security is also important, so that AI does not intrude our firmware or and then the corrupt hardware. So some kind of signature mechanism, all this can be implemented in FPGA. So idea is create some IP core in an prototype or product version from the FPGA point of view. Create a hardware software SOC equivalent build from FPGA point of view. Finally, go to microcontroller migration to probably have you know ASIC. Okay, so these are, and then come to the AI ML accelerator. You already are familiar with, I mean, all this tiny ML quantization kind of stuff for IPs. Uh, edge, edge and small devices. Okay, we very much need this quantization for int 8, int 4, dynamic quantization, pruning. Can we have a dedicated CNN convolution network IP, or maybe a dedicated or configurable unit? Usage of RISC-V plus ISA extension. I'm not sure. Can we do some kind of custom opcode like Mac or those kinds of configurability in terms of RISC-V extension, which we can basically use and call our own deliverable. NOC is also picking up for complex SOCs. So NOC is one such thing probably. Chiplet is another such thing. Basic multi-core match, dynamic routing, all this can be done. Again, can we create some kind of SOC with our own custom knock with basic features and demonstrate something in terms of video streaming or audio streaming with AI, or probably those kinds of things as part of this. So this is what actually we possibly can do. Some of the closing ideas, or probably I can call as a suggested roadmap, Anushka and team would be have some kind of pick up out of this 100, 5 to 8 ideas, put those people who have skills or those who have will, interest. For me, my experience has been that program management and mentorship and leadership is needed from the point of view of ensuring that we have rock solid roadmap for this particular IP from what we want to achieve. For example, say FFT in power measurement or FFT in power spectrum analysis. Uh, we should ensure that what are the tangible outputs we are going to achieve, who are the people who are going to work on it, okay, and how do we do a cross-functional assessment, cross-functional overlap with whatever time all of us have. Okay, or maybe there can be some regular ways, regular schedule for this. Ensuring that something does not work, how should we do? What are the debug points? What are the test measurement probes and all this? I think remotely we can achieve 60 to 70% with a common kind of tool chain, common kind of a strategy for program execution. In case if we want to of course do a brainstorm in person, face to face, whiteboards, debug, and use some kind of equipment, we should also ensure that we have those kinds of things available. These are all in most cases costly. We'll finalize how can we utilize this, a dedicated lab maybe in Bangalore, some part of the Bangalore, maybe in Delhi, or maybe in wherever, uh, uh, maybe Nagpur or Hyderabad, whatever, right? So basically a Bharatiya semi lab with this classroom in case of debug to be done should be possible once a week, once in a month, or before the final prototype delivery. All are possibilities. It is just limited by our will to this kind of activity, or this kind of I don't know, maybe thought process. We have not been seeing in the current curriculum or in the current spectrum of the education system. I mean, I have myself interviewed more than 1,000 people for the embedded system job or for the VLSI kind of job, and I see that they are not able to answer something beyond UVM or beyond physical design questions, or beyond AXI protocol, or beyond some of the basic C based constructs. The need of the hour, in my opinion, is we should have a product system understanding from the school based students, undergrad students, people working on professionals who are basically wanting to really get exposed to the product, if they are only focusing on, or if they are only on the job or something. So this is very much a soft skill versus hard skill, and willingness to apply our own till the prototype stage. We are actually making a real product happening with a collaborative thought process. I will leave some of the rules to be designed decided by Anushka for the production. And basically, once you are done, minimum viable product till the production. Of course, all these things are available. We may have to decide, can we participate in some kind of funding opportunities? Can we participate in some kind of once the FPGA is done? How do we get the this commercialized? Can we file something in terms of licensing, in terms of patent, in terms of innovation? Of course, once the teams are formed, can we do something with respect to getting the crowd supply, crowdfunding, or in incubation? Can we regroup this team for a particular potential of one of the team is working on some of the one of the IP core or one of the system pipeline? Can we go to the Indiegogo? Can we go to other Kickstarter or those kinds of things? These are the things which probably we should set and close those rules. But once one such project is executed, and we have all this phase one and phase two done, basically we are completing the whole life cycle of the product, from the FPGA as a core, software, hardware, and system at the periphery, and basically do this IP or system or SoC or FPGA product ready from the point of view of lending or giving to customer, making it more robust, and exploring other innovative or licensing options. I see this has been interesting and has been missing in the so far whatever mushrooming training institutes, or the batch of students which are coming post 12th class or post engineering or computer science and electronics. This can make a lot of difference if we set us to do. I think at least 5 of 10 such things happening. There is a lot of opportunity for 100 plus such innovative ideas team.
Yes.
Okay, it is
Yes.
just matter of you guys saying yes. We start, we will fail, but following up a process, following up on program management, ensuring that the transparency is there, and we are patient, as I said in the beginning, right? I think we should be able to achieve pretty much a good amount of satisfaction, huge learning, and finally you can decide what you want out of it. Okay, let us start. As I say, it is not about hardware, it is not about software, it is about system. We'll
Right.
learn, we'll solve, we make. It's all about, again, forget about make in India, forget about China, forget about US. We are there, we can change ourselves. Let us manage ourselves. I think that is what is the most important learning,
Right.
and confidence we can get.
Yeah.
Guys, I think I am done. You should ask some questions if you have. Otherwise, I'm open for
So
any
they are
message.
asking for your LinkedIn.
Yes. I think we are done. 1 hour, 15 minutes.